Hello friends, welcome you in this video tutorial. In this video tutorial, we are going to talk about association, aggregation and composition in Java. So when we talk about the association, an association is a structural relationship in object-oriented modeling that specifies how objects are related to one another. This structural relationship can be shown in two forms. First, using class diagram associations, or second, use case diagram association in UML, right? An association may exist between objects of different types or the between the objects of same type as well. An association in UML is drawn as a solid line connecting objects of different classes or two objects of the same class. If you want to show navigability, then you can use arrow at one end and or at both end for bidirectional navigability. So here you can see we have two classes like class A and class B, and from class A to class B there is a navigation. So class A basically somehow related to the class B. Here you can say class B is navigable from class A, and that's the way basically represents association in Java. There are many types of association. A class can related to another class in various way, like you have a one-to-one association, one to many, many to many, many to one. These are the basically associations can have a between classes. Now when we talk about the aggregation in a plain association, classes are basically, first of all, to exist aggregation relationship there would be some association, right? So classes are considered at the same level with one class having no more in importance than the other, right? Sometimes you do need to define a whole or part relationship where one class that is considered as a whole consists of the smaller classes that is considered as a part. This kind of relationship is called aggregation. It is also known as a relationship, as object of whole has object of part. And aggregation in UML is drawn as an object open diamond at the whole end. So here you can see employee is related to the company, right? Company can have a person, right? A person can have person is related to the company. So one company can have a one or many persons. So here you can see diamond, one diamond symbol, right? Open diamond symbol. So whenever you see open diamond symbol, that means this represents the aggregation in UML. Now next relationship we have a composition. As we have seen, aggregation relationship makes a distinction between whole and part, but does not force an ownership, and it also doesn't link the whole and part object in such a way that if whole is destroyed, parts are also destroyed, right? There is a variation of aggregation called composition, which has basically strong ownership. Thus the scope of the whole and part are related. In composition, if there are two classes, class A that is considered as a whole and class B that you can consider as a part, then destruction of class A object will mean class B object will also does not exist, right? Which also means class B object may be a part of class A object only, right? So once you destroy the class A and class B is composed inside class A, so class B also gets destroyed in the composition. So this is kind of tight, what can you say, tight association, and aggregation is a loose association, you can consider like this. Like, so composition in UML is drawn as a filled diamond at the whole end. So you have a department, and one school can have a many department. Now there is a relationship from department to school, and here you can see diamond character, diamond symbol with filled diamond symbol. So in UML, basically if you have an empty diamond, then that is called aggregation. If you have a filled diamond symbol, then that is called composition, right? So that's all. These are the things basically we understood theoretically. Let's go through an example. So here I have created an example, aggregation and composition example, and I have a 3 model classes: address, employee and person. Here I am going to show you where basically how aggregation basically exists and how basically composition exists within your source code. Now here you can see we have an employee, and employee is having some primitive as well as string data type instance variable. There is a one more basically instance variable, is called address, and address is having our own class, separate class, which is having own fields and public setter getter method, right? So here this relationship, right, relationship between employee and address is called aggregation, right? So if you have an employee object, and employee is basically also holds the information of address, so here employee and address can exist independently, right? So here is the client program. Here you can see I have created two basically a local method, private method. So first of all, this method aggregation demo shows how aggregation basically works. So here we have a address. We have created an object of address, and we are setting all its fields by calling setter method. Now we have an employee, and employee is having some private fields, I mean a string as well as primitive data type, so that we are setting over here. Along with address we are setting as well, right? So let's say you are trying to print the employee, and here we have overridden two string method in employee, so this will print the state of object in nice format. Now if you try to print employee, then this will print the employee as well as address information, employee address information. But once you nullify let's say employee, right, and that is a whole, right, as per the slide, employee is considered as a whole, and here employee is considered as a whole, and address is considered the part, right? So part is contained by whole. So once you try to nullify the whole, still part can exist independently, still address, if address is independently, right? So address you can print as well after nullifying the employee, but employee will print as a null. If I run this application, so let me run this application, and here you can see if you go to this example aggregation demo, then initially we have printed employee. So employee state is getting printed along with the address. Now once we nullify employee and we try to print the employee, then employee is coming null, but address we can print, because address is a separate object, this can exist independently, right, and address is getting printed, right? So this is kind of example of basically aggregation, and this is also referred as has a relationship, means I can say employee has a address, right? This is a has a relationship. Now another example we are going to see, that is composition, right? In composition, the containing object is responsible for the creation and life cycle of the content object, right, either directly or indirectly. We can do with it constructor initialization. In this code you can see while initializing the person, we have instantiated employee, right? So employee is basically we have instantiated address. So address is the basically composed within the person, right? So here we have two classes, person and address, and here address basically object is contained within the person class, right? So here it can be seen that address class object is created and destroyed along with the person class object. So here in client program, before that let me show you all the code within the person. So person is having some private fields, and one default constructor, there we have instantiated address, and we have a setter getter method of these fields, and only getter method of address we have provided in the last, right, and we have overridden two string method. Now if I go to the client program, and here let me run this composition demo. This is our private method. Here we have created person, and we have setted person all the fields, and after that person is having a get address, so this will return the reference of address, and we are calling the setter method on the address reference. We are setting city, address line 1, address line 2, as well as a street, right. Now when we print the person, this will print the person information as well as person information as well. But once I nullify the basically whole object, that is called employee, then part object, that is nothing but the address, will be destroyed along with the whole object as well. So here in client program, if you nullify person, right, then along with person, address will be destroyed as well. So if you after nullify, if you try to print person, then person will be null, and here before calling on person get address, of course you need to check the not null, and that's what not null I have applied. So if person is null, of course we are explicitly nullify, so of course else block is gonna execute, and this will print address doesn't exist, right. So if I run this application, you will have a time, we will have an output something like this. So initially we have printed person, so person is getting printed along with the address, but once we nullify the whole object, then content object is also getting destroyed or nullify, and that's the reason person is coming null, as well as address is also saying that address doesn't exist. So basically when we talk about the composition means this is a association kind of tight coupling. So if whole object destroyed, then a part object is also getting destroyed, right. So that's the basically life cycle goes on with composition. So that's all I have in this video tutorial. I hope you enjoy learning this video. If you really like this video, then hit on the like button and don't forget to share and subscribe my YouTube channel. Guys, big thank you and see you next video tutorial.